In this video, we will look at lights and materials. There are 4 basic types of lights that are available in most rendering systems. They are point lights, spotlights, directional lights and ambient lights. The point light emits light in all directions equally. The spotlight emits a directed cone of light. With both these lights, the light intensity will drop off with distance from the light source. With the spotlight, the intensity also drops off with distance from the center line of the light cone. The directional light emits uniform light in a particular direction. The ambient light emits a completely uniform light in all directions throughout the scene. With both these lights, there is no drop in intensity with distance from the light source. The rendering process needs to consider 2 types of illumination, direct and indirect. Direct illumination is light that travels direct from the light source to the surface. This type of illumination is fast to calculate. The image on the left was rendered using direct illumination only. The scene includes multiple light sources, in order to try and mimic the effect of light bouncing around the room. Indirect illumination is light that arrives at the surface by bouncing off one or more other surfaces. This requires a lot more computation. The image on the right was rendered using the radiosity algorithm, which takes into account indirect illumination. Both scenes contain only one light source. The lighting in the second image is much more realistic. Next, let's look at some materials. Materials define how objects appear in the model. If you render a model without specifying any materials, a default material will be applied automatically. However, you can also apply your own custom materials. There are different types of materials that can be defined, for example for matte materials or for shiny materials. These materials have properties that define the way they look. We will start by looking at some of these properties. The way that light bounces off a material affects how it looks. In general, when light hits the surface of a material, there are 2 ways that it can be reflected. Diffuse reflection is a type of reflection that scatters light in all directions, due to the roughness of the surface. Specular reflection is a mirror-like reflection, where the light bounces off at an equal angle. The color of a material is typically defined as 3 values: diffuse, specular, and emissive. The diffuse color is the main underlying color of the material. In the example, the diffuse color is red. The specular color is the color of the specular highlights. In this case, we have set it to blue, to make it clearly visible in the image. Often, it is set to white. Finally, the emissive color is a color that is emitted by the object, even when there are no lights present. The light that is emitted will not affect other objects. In this case, we have set it to black, which means there is no emissive color. It can be used to add a little brightness to an object. Typically the color will be very dark. The objects in the model can also have vertex colors that differ from the material colors. In this case, there are 2 approaches to calculating the final diffuse color of the material. Either the material color can override the vertex colors, in which case all vertices will get the same color. Or the material color and the vertex colors can be averaged, in which case each vertex will have a color that is the average of the material color and the vertex color. In the example image, the material diffuse color is white, and the vertices all have different colors. The opacity of the material can be set as a parameter between 0 and 1. 0 being full transparent, and 1 being fully opaque. A scene can have objects with different types of materials. Each material type has a particular set of properties. And each material type has a shader, which is a small program to render the material. The properties we just discussed are properties found in many material types. Let's take a look at some example material types. We will use the 3.js library as an example. It includes a series of materials for meshes. These material types are common to many rendering systems. We will take a look at 4 materials. 2 are non-PBR materials, and 2 are PBR materials. The 2 non-PBR material types are Lambert and Phong materials. Lambert materials are for non-shiny surfaces. Phong materials are for shiny surfaces with specular highlights. The 2 PBR materials are more advanced and can be for shiny surfaces. They give a more accurate and realistic-looking result than the Lambert and Phong materials, but at the cost of being somewhat more computationally expensive. The PBR physical material is the same as the PBR standard material, but with more control over reflectivity. Phong materials use a shininess parameter to describe how shiny the material is. The value varies between 0 to 100. PBR materials use metallic and roughness parameters instead of the shininess parameter. The metallic parameter describes how much the material is like a metal. Non-metallic materials such as wood or stone should be set to 0. Any non-metallic materials should be set to 1. The roughness parameter describes how rough the material appears. The table gives an overview of the different materials and some of their main properties. Finally, environment mapping allows materials to reflect a set of images that define the surrounding environment. The images represent a distant environment surrounding the rendered object. Environment mapping is an efficient way of approximating the appearance of a reflective surface. However, there are 2 key limitations. First, the environment is assumed to be at an infinite distance. Second, environment mapping does not include reflections of any other objects in the scene. Only the environment images are reflected. Finally, materials can also make use of images. For example, the diffuse color of a material can be defined using an image. The image is then mapped onto the 3D object. The mapping follows certain rules that specify how the image wraps the object. The use of such images is not just limited to the diffuse color. They can be used to define many different types of material properties, including properties such as transparency, roughness, or bumps. These images are generally referred to as texture maps. In the example, the diffuse color of the sphere is defined using a texture map. The image is wrapped around the sphere so that the surface is completely covered.